little bit closer. Okay, here we go, a big one. Off the ground, one more.
Today on the show we have Jeff Crawford. He has a master's degree in electrical engineering and was in the space industry for 40 years. He is an amateur radio enthusiast and author of the book High Power HF Filter Design. We have him on the show today as a subject matter expert to debunk the moon landings were a hoax conspiracy theory. How are you today, Jeff?
I'm just fine.
Could you please give us a quick overview of the communications involved in Apollo and why it would be impossible to fake them?
All right. The frequencies that were used by the Apollo mission to go to the moon were 3 gigahertz. And as we know, there were multiple ground stations around the Earth because just due to the rotation of the Earth, one ground station could not continually see the moon. So you had to have multiple ground stations. Diego Garcia, Hawaii, Spain, multiple places. Radio communications are line of sight. So if you can't see the moon or you can't see the Apollo vehicle as it's going to the moon, you're not going to be able to hear their communications. These antennas, specifically these large dish antennas, have a very, very narrow focus. And so they have to, at 3 gigahertz, they have to be pointed within about 3/10 of a degree. So a circle has 360 degrees. You have to be accurate within about 3/10 of a degree. And if you're off practically at all, like a tenth or 2/10, you will either have degraded signal to noise ratio, in other words, degraded intelligibility, or you may not get the signal whatsoever. And so this is extremely important from the standpoint that if you were going to try and mimic a moon landing, every ground station has its own particular pointing requirements from its location to the moon. And every ground station will have a different solution set. Not only that, but we know that there were thousands of people around the planet eavesdropping on the Apollo frequencies. As a high school student, I wrote NASA, and I actually got the frequencies from NASA. So this was open source information. There were thousands of people with their own receivers and antennas across the planet listening to this. So it's not just you have to fake out mission control and or the ground stations. You've got thousands of other people that would see that there was something anomalous. And not only that, but right now my comments have been just on the receive side. On the transmit side, you've got somewhat the same thing. Any transmissions that would take place, people on the ground near those stations would be able to hear the signals. And if those were absent or they were coming from an anomalous direction, that's a further clue that, well, this isn't real. None of that happened. None of that happened.
Right.
So the communications in and of itself is very, very noteworthy of the evidence that, yes, indeed, it happened.
Right, because you have numerous ground stations involved around the surface of the Earth, all of which are operating under, they have to do very precise calculations, going back to that 0.3 tenths of a degree you referenced, to know where to point the satellite out in space to capture the signal. And they all have to coordinate with each other for continued coverage while Apollo is out in space.
That's right. And if you were going to try and mimic this, you would have to have so many assets deployed in orbit in specific places because, again, if you're not in that line of sight from the ground station to the moon within, I'm going to use 3/10 of a degree, but that angle changes with the distance from the Earth. If you're not within that kind of narrow window, you wouldn't be able to pull off the hoax. And the amount of rocket fuel and station keeping and orbit maintenance across perhaps hundreds, maybe even thousands of deployed satellites, it's just mind-boggling. We couldn't do it today because It's not like Star Trek where we just hover above a planet just where we want to and defy Kepler's laws and the laws of gravity. It just doesn't work that way.
Right, and not only would you have to mimic the vector of the purported direction of Apollo and where the signals are going and being received from, but also you would have to mimic the time delay involved, right? Like when they're at the moon, the time delay is roughly 1.3 seconds.
And that's just one way, right?
Correct, right.
Yes, and in today's modern era of all our digital signal processing and fast what we call A to D converters, where we can capture a signal like that, it's very easy to introduce that kind of delay. Back in the 60s, it was a phenomenal feat to do, because what you had to do was you would introduce a signal into a length of cable, and that cable, if it was long enough, it would introduce the delay that way. The problem, though, is to introduce that much time delay, the cable would have to be many miles long. And associated with that length of cable, you would have all sorts of signal loss. And so you would lose what we call signal to noise ratio. And any scientist or engineer would know that there was something amuck going on. And again, yes, there are some things you could do, like have intermediate amplifiers here and there, but it's still, the hoax is harder to pull off than going to the moon in the first place. So just go to the moon.
Right. And from my understanding, not like if you were to have satellites in orbit to mimic the vectors of where Apollo supposedly was in space, you would not only have to mimic the vectors, but also the speed of which Apollo is moving to and from the moon.
That's absolutely right, because part of any certainly interstellar communication system is the operators have to be aware of what the accompanying Doppler shift is, so that they have their receivers not only tuned to the right frequency, but that frequency is going to vary with time and position. And they're expecting a certain range of Doppler shift, and if that were not there, everyone would start scratching their heads and wonder why. I mean, this would be a dirty fingerprint on this whole scenario, and again, that would unravel any kind of hoax attempt unless you took care of Doppler shift.
Right. Okay, well, Jeff, that was a very good overview. Thank you. Could you briefly give your opinion on why you think it is 55 years later we can't get back to the moon?
Well, we're getting closer, and SpaceX has made some tremendous inroads there. But not that many years ago, when we had like a Titan IV or other of the largest launch vehicles that the United States was using, believe it or not, those rocket engines we bought from Russia. We did not have the technology, the manufacturing facilities, et cetera, to make those large rocket engines. We lost that sometime after we went to the moon. And just because you can do something in 1960 doesn't mean that you can pick it up 10 or 20 years later and do it. We can lose the recipe on these complex technologies, and it's difficult to reconstitute. After the Challenger accident back in the late 80s, we had, as a country, aligned ourselves with using the shuttle as an avenue to space. We had discarded this idea that we were going to use expendable launch vehicles. Everything was going to go up on the shuttle. Well, we can't do that after that shuttle explosion until we figure out why it exploded. I was working for a company in Los Angeles at the time, and it was a think tank company. And we were sending people up to Vandenberg Air Force Base weekly for months, trying to reconstitute how you use these deployable launch vehicles that were used prior to the shuttle. And I don't know the count, but I would suspect somewhere between a half dozen and a dozen explosions of launch vehicles took place over the Pacific because we were trying to reconstitute the knowledge and know-how required to use these expendable vehicles.
That's interesting. And also, it's also due to the fact that we're very risk averse as a society in general now, isn't it?
I would say that's one of the. I'm not sure if that trumps the availability of the rocket engines. It very well may, because as a society, we're just not willing to do what we did during the Apollo era to get to the moon. The heroics that people went through. I actually had some friends, they've long since retired and passed away. They helped with Friendship 7 when John Glenn had all these problems in the early Gemini program. The heroics these people went through in order to make these things be successful for the United States. Our society is unwilling to do it today. Not only are they unwilling, but society is so risk averse that we won't take those kind of stands and really go after it like we did back then. Back in the 60s, there was no way, no how the United States was going to come in second to Russia. And that was everybody's mentality, everyone.
Right. Okay. Well, I think that's a very good overview of everything. Jeff, I really thank you for stopping by today and lending your expertise on the subject.
Thank you very much. I hope you found some of this interesting.
Yeah, absolutely, and we hope to have you on again sometime.
All right.
All right. Bye.
Bye.